Hello guys, this is the continuation of one of the topics of chemistry regarding type of chemical reactions. So this is the part 2 of my discussion, and I had finished a while ago my first part of discussion. So now we need to illustrate examples, but before that we need to recap the acronym of that type of chemical reactions so that we will not forget. Okay, should it be retained in our mind or not? So if it should be retained in our mind, then we need to have acronym because it's not easy to memorize also. Okay, word by word. Okay, something like that. But if you want, it's up to you. But we need to have hint, HINT, clue, CLUE, and the acronym for easy understanding and recalling the five types of chemical reaction. So what are those five types of chemical reaction? Again, SDCSD. Okay, S means synthesis, okay, or combination. D means decomposition. C means combustion. Okay, S means single replacement, or it could be called as single displacement. And the last type of chemical reaction will be the double replacement or double displacement or double replacement. Sorry for that, nabubulol. Okay, like that. It is the main reason also that I will not be able to do my vlogging in Tagalog because my tongue will be what do you call this one, twirl like that, nabubulol, something like that. So if I will do that also in Bisaya, then there are things that cannot be explained with Bisaya also, especially terms in English that have no equivalent in Bisaya also. So the best way to discuss is through English medium of instruction to be safe. Anyway, anybody can understand English. Okay? Thank you for the understanding. And that would be so. Five types of chemical reaction. Okay. So I need to show you and okay, five types of chemical reaction. This is very basic and this is very helpful, especially in stoichiometry or chemical calculations. Okay, but you have now an idea before because I'd been discussing already about stoichiometric relationship, how to compute the gram to moles, moles to gram, like that. And I also discussed regarding the computation of the present yield, actual yield, theoretical yield, the limiting reactant, the excess reactant, okay, something like that. So this is very helpful because this is an initial stage predicting product reactants and products in the chemical reactions, what to expect, what will be the products, because there are problems, okay, especially in problem solving in chemistry, okay, that they will never do the representation of the chemical reactions first. They do it in statements or in words. For example, sodium sulfate react with barium chloride and it will give blah blah blah. So if you don't have an idea, so what those elements and compounds reacted together, okay, incorporating also the charges of each element and then made as a compound and added to another compound, for example, and then you will be lost in predicting the products also. Okay, then after you produce the products from that reactants, okay, then you need to balance the chemical equation, okay, something like that. And after that, perfect, you can start now your computations of what are the uh, things needed in the particular problem, or what are the required uh, things to be solved, or let's say amount, okay, in mass, in moles that are required to the particular chemical reactions. Five types of chemical reaction. Okay. The first one is the synthesis. Synthesis, okay? 5 types of chemical reaction. The first is synthesis. Synthesis is just like a combination reaction for me, okay? Combination. So it's just like a combination or synthesis. Let's start with the SDCSD. So here is our acronym SDCSD. Okay, synthesis, decomposition, combustion, single replacement or single displacement, double replacement or double displacement. Okay, so in short, replacement can be also known as displacement. Okay, like that's a combination example. Okay. A very basic example for this is carbon plus oxygen gas. Okay. Like this. This is a synthesis or a combination reaction. So what is expected for this? It will produce CO2. Okay. CO2. So this is a synthesis reaction. Okay. Like that. Or a combination reaction. So the product is CO2. Okay. CO2, which is a gas. Okay. Like we have to balance the equation. Okay. For carbon 1, oxygen 2, oxygen 2 and oxygen 2. So this is automatically balanced. Okay, like this. So if we try to give another example, magnesium, let's say manganese plus chloride. Okay, like this, manganese plus chlorides. Okay, this is positive 2. Okay, and this will yield manganese chloride like this. Another example is manganese plus chloride. So manganese, it has a charge of positive 2 and chloride has a charge of negative 1. So it will produce manganese chloride. So transpose each charge. Okay, the charge of manganese will be going to the Cl2 and the charge of negative will be going here. So it's supposedly 1, but 1 is simply as nothing. So that is manganose chloride. Manganose because it's 2. Okay, and if 3 manganic, something like that, but that's 2 manganose chloride or manganese chloride. Okay, no problem for that. Manganese chloride to make it safe. Okay, like that. Okay, and then as we recall on my previous discussion, okay, another reason why it become a manganese chloride. So we have 2 here and we have 1 here. So to compensate, we need another chlorine here. Okay, so like this. So negative 2 and positive 2, right? Okay, there are 2 chlorides, positive 2 to compensate the manganese 2. So other charges, positive 2, negative 2 is equals to 0. So it will be equal to Mn and Cl2 or MnCl2. Okay, like this. So since there are chlorine 2, okay, chlorine 2, so 1, 2 chlorine, okay, bracket 2, meaning chlorine and chlorine. Okay, so Mn chlorine gas, something like that. These are only 1 Mn. So another method for transposing, we have this one also. Okay, another method how to get this manganese chloride. Okay, this is synthesis or combination. We can have also water starting from hydrogen gas plus oxygen gas, it will produce water. So that is also synthesis or combination. Okay, like that. Number 2, we have the decomposition. Decomposition. For decomposition, we need to take 2 examples so that we can save our time. Okay, number 2, we have decomposition. By the way, the synthesis is just adding simpler substances to produce a compound, a single compound or a more complex compound. It depends on the reactant, something like that. So decomposition. Okay. Decomposition. But if you want to represent this in a variable, you can also have represent this carbon and oxygen and then CO2. So we represent this as here A plus B is equals to AB. So this is our general formula for synthesis. A plus B is equals to AB. You can have also X plus Y equals to XY. That's only representation and it has no relevance that much. The purpose is that for easy explanation only, that's gonna be like that. Okay, A represents one element, B represents another one element, and then AB represents the compound that produced during the reaction of A element plus B element, something like that. Okay, now we go to the decomposition. So decomposition meaning it will be undergoing a physical reaction. No, not really that physical, because when you applied heat, I think it's no longer physical, and then it will produce another product. So it will be a chemical change, right? Correct. Okay, that's chemical change. Okay, we will apply heat and then decomposing one compound to produce various products. Okay, something like that. For example, I have the calcium carbonate. Okay, calcium carbonate. Okay, so I have the calcium carbonate. So if we try to decompose this one, okay, normally by applying heat, okay, it's gonna be like that in usual cases. Okay, so it will decompose to what? In this manner. You know that there's oxygen, there's also carbon. So usually it will yield CO2 first because of the carbonate thing. Because of the carbonate thing, you will engrave that in your mind that it will produce CO2. In any reactions, if it has carbonate, always have a CO2. That's the technique. Okay, like that. And then the other will be the compound itself. Okay, so it could be CO2. So it could be a solid first, the calcium carbonate, right? Let's say solid first, the state, and then gas, and then plus calcium oxide. Okay, like that, like this. So this is also solid. Okay, like this. Calcium carbonate, which is in solid state or a compound, will produce carbon dioxide plus calcium oxide, and then we need to balance the equation after this one. This is the decomposition. Okay, by heating the calcium carbonate or any other means of splitting or decomposing this calcium carbonate. Okay, there's a lot of processes, right? So we need to take only by the application of heat. Okay, like that. Okay, balance the equation. Okay, calcium 1, calcium 1, carbon 1, carbon 1, oxygen 3, oxygen 3. So balance the equation. Okay, automatically balance the equation. Calcium carbonate will decompose into carbon dioxide plus calcium oxide. So if we leave this as a variable, we have now AB is equals to A plus B. Okay, like this. AB is equal to A plus B. So in short, this is only the reverse for the synthesis of combination, which is A plus B is equals to AB. Okay, like that. Okay, number 3, we don't have to show you so many examples, as long as you have an idea that's gonna be like that. Actually, there's a lot. For example, carbonic acid, like that, will decompose into water and CO2, something like that, and a lot also. Even the water will decompose into hydrogen gas plus oxygen gas. There's a lot of compound that will try to decompose or break up or dissociate into another various elements after the application of different chemical processes or physical processes. Okay, but normally we're trying to apply heat only as our basic example for this decomposition reaction. Okay. Number 3, combustion. Okay, combustion is very common in different industries. Could it be the power plant industries like this, geothermal power plant? Okay, what else? In manufacturing of rubber, something like that. In plastics industries, okay, like that. This is very common. And then in what else? In the mining industry, okay, and then in metallurgical industries also, like that. So this is very useful, the combustion reaction. Okay, our example will be mainly, we'll start first for the combustion of organic compound. Okay, like that. Organic compound meaning mixture or combination of carbon and hydrogen. So let's say start with methane gas, okay, plus oxygen gas is equals to CO2 plus H2O. Okay, like this. Methane gas plus oxygen gas, or the rapid oxidation of oxygen. This is a combustion reaction. If you add oxygen, there's a rapid oxidation, and it will produce CO2 plus H2O. Okay, this is a combustion reaction for hydrocarbon. Okay, then we need to balance the equation. Carbon 1, oxygen 2, oxygen 2, oxygen 2 plus 1. Okay, carbon, oxygen 2 plus 1, hydrogen 4, hydrogen 2. Okay, so the hydrogen is not balanced and the oxygen also is not balanced. Okay, 4 is equals to 2x here. Okay, so 4 is equals to 2x, x is equals to 2, and this is equal to 2. Okay, 2 moles of H2O, and then balance the oxygen. Okay, oxygen is 2 plus 2, 4, and then oxygen balance. Oxygen balance, the oxygen is 4, and then here also X for oxygen again. So X, therefore 2x, 2 times x is equals to 4. 2x, so 2x is equals to 4, x is equals to 2, so 2 here. Okay, like this. So methane plus 2 moles of oxygen gas is equals to carbon dioxide plus 2 moles of water, 4 moles of oxygen balance, 4 moles of hydrogen, 4 atoms of hydrogen balance, 4 atoms of oxygen balance, and 1 carbon balance. This one. Okay, like this. This is a combustion reaction, and a lot will follow. The combustion of ethane, propane, butane, and combustion of ascorbic acid, citric acid, lactic acid, or anything in organic compound, or inorganic compound also can be combustion. Okay, as long as it is a compound added with oxygen gas. Okay, number 4. We have single replacement. Let's say number 4, single replacement. Replacement or displacement, right? It's just the same. Displacement. So let's say I have the let's say ferrous chloride plus manganese. This only example ferrous chloride plus manganese. So what is the formula of ferrous chloride? So this is FeCl2. OUS, ferrous is positive 2 is our charge for the ion Fe. Okay, and the chlorine will transpose. This is gonna be the formula of ferrous chloride. Okay, so ferrous chloride plus let's say magnesium. This one magnesium, right? So ferrous chloride plus magnesium. That's only an example. Okay, like there's a lot of examples if you want to try it. Okay, and then we represented this as AB plus C. Okay, like that. Okay. Okay. AB plus C. And in this case, for single replacement and double displacement later on, we are very interested for the charges, because this is reacting the positive charge and negative charge in the reactants to produce the products. So it would be helpful to illustrate the charges of each element or compound in the reactants. Okay, like this. So this is the negative chloride or chloride. Iron is positive 2, and this is the positive 2. Okay, so there is a rule that the negative and the positive will react. Okay, so what is positive and negative here based on the charges? What is the positive and negative based on the charges? It's the chlorine gas and the magnesium. Okay, so this chlorine gas and this magnesium will react with each other. Okay, you understand the point? So this magnesium will attract the chlorine gas, meaning to say this magnesium will pull out the chlorine gas, and what's left is the iron. This is gonna be our product. Okay, so like this. Okay, like this. So it's gonna be BC plus A. It's gonna be like this. BC, AB. Okay, AB. Sorry, AB plus C. AB is our ferrous chloride plus C, our magnesium, is equals to BC plus A, because our B, this one, our C is magnesium. Okay, chloride will react with each other. Okay, this is CB. You have to be careful because it should be the positive first. Okay, for the purpose of discussion only, positive first and then later the negative during the compound combining with each other. It should be the positive first and then the negative. So the positive first, the C is our magnesium. So this is the C, magnesium, right? Okay. Okay, and our B is the chlorine gas. So put that here, the chlorine gas. And our A is the iron. Okay, that is like this. So our product for ferrous chloride plus magnesium, this one, ferrous chloride plus magnesium is equals to magnesium chloride plus iron, and then we have to balance this one. Okay, so Fe1, Fe also is 1, and then chlorine 2, okay, manganese 1, magnesium 1, magnesium 1. So this is totally balanced, directly balanced. So I illustrated an example that is automatically balanced, which is the ferrous chloride plus magnesium is equals to magnesium chloride plus iron. Okay, so in a single replacement or displacement, you need to take account the charges in reacting with each other. So this is the general formula. AB plus C is equals to, okay, CB plus A. Okay, like that. Okay, now the last will be the double replacement and double displacement reaction. So we'll try the examples to make it easy so that we cannot think of any other chemical reactions, because there's so many chemical reactions. Okay, so in our example will be the common one. Okay, we need to try the neutralization reaction. Okay, as we can remember, this neutralization reaction is a reaction of a strong base plus a strong acid to produce salt and water. Okay, and the reverse will be the hydrolysis, and we don't take the hydrolysis. Okay, something like that. Okay, and this is special because it's added by water. Water is special when you add it to compounds. The rule is another thing. It's not direct. Okay, rather than saying magnesium chloride plus sodium sulfate, and it's easy to have a reaction in a double replacement and double displacement, right? But in a neutralization reaction, there's something special. I will show you. Number 5. Double replacement and displacement. So this one, AB plus CD is equals to AD plus BC. So this will be our general formula. Okay, for our double replacement and double displacement. Okay, AB plus CD is equals to, okay, you can see now, that's it. And then we represent examples for that. Let's try AB for strong base. So strong base, that is sodium hydroxide. Okay, sodium, because base is hydroxide, right? Sodium hydroxide. negative, positive. Okay, plus CD, strong acid. Okay, so H and D, Cl negative. Okay, so okay, a strong base which is a sodium hydroxide in which have charges, okay, sodium positive 1, okay, hydroxide negative 1, plus hydrochloric acid HCl, H positive 1 and chloride negative 1 will yield, okay, a salt and water. Okay, salt and water. So that's AD, meaning to say sodium chloride. Okay, this our A is sodium. Our A is sodium. Okay. Our B is hydroxide. Our C is hydrogen or H plus. Our D is oxygen. Okay? No. Chloride, sorry. It's very easy to, it's very difficult to discuss like having this on paper only, right? So NaOH. So our D is chloride. Our C is H. Our B is OH and our A is Na. So AD. So sodium chloride. Okay. Negative plus positive is sodium chloride. Okay. Like this. So sodium chloride. And then Bc will be now equal to H2O.